I'm Mr. Tappy, and thank you for watching my video, part 3 of balancing chemical equations. So as you can see here, I've selected a problem that was a little more difficult than the other two, or I should say the other one. And so let's get started. So the first thing that we need to do is we need to take inventory of the elements that are inside the chemical equation. So as you can see, we have sodium on this side, we have chlorine, and we have fluorine. So those same elements will be on both sides. I'm going to go ahead and use the method number 2 that I showed in my part 2 video. The reason is because it could be a little bit easier to understand, and if you've already understand balancing chemical equations from the first video, then this one is actually pretty easy. And so let's get started. So the first thing we need to do is we need to look at these elements. And so we have sodium and we have chlorine, and as you can see, they don't have any numbers next to them, but that just means that they're one atom each. So there's one sodium atom and one chlorine atom. And so I'm going to go ahead and write those out. And as you can see, so let's see, we have sodium and chlorine. They move in sets of 1 because there are no numbers. And so we have 1, 2, 3, 4, 5, and 6. And the chlorine also moves in the same direction. So if I put a 1 here in front, it makes 1 sodium and 1 chlorine. If I put a 2, it's 2 sodium and 2 chlorine. And so we'll just go ahead and line these numbers up as best we can. Okay. Now the second element here is fluorine, or the third element I should say, and so we'll go ahead and mark it. Now as you can see, it has 2 here, so if I put a 1 here, that's not a 1, if I put a 1 here, 1 times 2 is 2, if I put a 2 here, 2 times 2 is 4, and so as you can see, it moves in sets of 2 based on this little number here. And so we have 2, 4, 6, 8, 10, and 12. So we're going to move across to the reactant side. We have NaF, and of course we're going to keep them together. So we have NaF, and as you can see, they move in ones as well. So we have 1, 2, 3, 4, 5, 6. Remember, these sodium has no numbers next to it, so that kind of means that it moves in ones, and fluorine also has no numbers next to it, and so it moves in singles. All right. The last one we have is chlorine, and as you can see, chlorine, Cl, moves in 2s. It has this 2 here, and so we go 2, 4, 6, 8, essentially multiples of 2. Alright, so I guess the biggest question is, where do we start? And if you'll look at these elements, you can pretty much start anywhere you want. I like to start with a molecule. A molecule is a collection of 2 or more elements. And so as you can see, there's a molecule here, and there's a molecule here. I know from chemistry that fluorine is the most reactive, and so I'm going to go ahead and start here, and I'm just going to circle the first selection. So given that I have sodium and fluorine, I have 1 and 1, I'm going to go to this side and see if there's one that exists. So is there a fluorine that has a 1? No. The smallest that I can do on fluorine is a 2, and so this one cannot work. So I will move down to the second one. Can a 2 and a 2 work? So can the number 2 work? So we have 2 sodiums and 2 fluorines. So is there a number on the product side that has a 2 for fluorine? So you have fluorine here, and then you have the 2 here. So is there a number? Yes, there is. And so this one can work. So going back to our original number that we circle, we have 2 and 2. Is there a place on the product side that has a sodium that's a 2? So is there a place that matches this? Well, yes, there is. It's right here. Now that we're here and we've gone ahead and selected it, we look at the chlorine. So is there a place on the right side that has a chlorine? So is this 2 represented somewhere on the chlorine side? Well, the answer, of course, is yes. It's right here. And I'll go ahead and get a different color for you. So what does that mean? Well, that means that we have a fully balanced chemical equation. All we have to do now is count how many spaces down we had to go. So 1, 2, we went 2 spaces down, so this will be a 2. As you can see here, we went 1 space down, so that's a 1. 1, 2, this is a 2, and this one is just 1 space down. So I guess the question here is, did it actually balance? Well, as you can see, we have 2 sodiums, and we have 2 sodiums. We have 2 chlorines, 1 times 2 chlorines. We have 1 times 2 fluorines, and 2 times 1, which is 2, fluorines. So we have a fully balanced chemical equation. I hope you enjoyed my video. Thank you for watching.